Hello, everyone. I'm really excited to be here and actually meet so many familiar faces. My name is Gamanji, and currently I am a senior field engineer at Apple. I have joined Apple 3 years ago, and as part of this role, I am bringing Kubernetes and cloud-native expertise to different teams and products within Apple. In addition to that, I'm part of the TOC, or Technical Oversight Committee, which is part of CNCF. As part of this role, I'm joining 10 other champions within the industry, and we aim to provide a technical vision for the wider CNCF landscape. In addition to that, I'm part of the TAB, but in this case, we aim to bring the end-user perspective to the projects within the landscape. I have many other roles in the community, one of them being the creator of the Cloud Native Fundamentals course, which is completely free, and you can find on Udacity. And in addition to that, I'm an industry-level awarded professional, and I have been awarded with a Next Generation Leader by Women in IT Awards and Tech Women 100 within the UK. Today, however, I would like to talk about sustainability chronicles, and more specifically, how we can innovate for green technology by using tooling such as Kepler and KEDA. And to begin with, I would like to start with the notion of cloud sustainability. Here, I would like to emphasize why it is important for the tech sector to observe, assess, and address their emissions. Next, I would like to move towards how we can apply sustainability to a cloud-native context. And here I'm going to introduce tooling such as Kepler and the KEDA Carbon Aware Operator, which will allow us to create an inventory of our emissions and scale our workloads based on carbon intensity. And finally, I would like to focus on community sustainability. Now, whilst the technology is the gravitational point of our ecosystem, none of it would be possible without a community around it. As such, I would like to emphasize why it is important for us to scale at the same pace with technology evolution. But before I move forward, I would like to congratulate our community for reaching a wonderful milestone. Kubernetes turned 10 years old this year, and we had wonderful celebrations all around the world. Now, as a community, we need to remember that we are working on software that really changed entire industries and sectors and how they approach infrastructure build-out and management. And over time, we had multiple tools built around from Kubernetes to extend its functionalities, such as support for different security, observability, networking, runtime, and so much more. And this created what today we know as the cloud-native landscape, which resides under the CNCF umbrella. Now, with the TOC, working individually, we follow these projects, and we work with them during sandbox inclusion or the project moving levels. Now, currently within the CNCF, we have more than 190 projects which are dispersed across 3 different levels of maturity. We have sandbox, incubated, and graduated projects. Now, sandbox projects provide this greenfield idea for a niche problem space. These are the emerging trends and the emerging technologies. Next, we have incubated projects, and here we already see adoption in production, but more importantly, contributions from different organizations. And finally, we're going to have the graduated projects, and we refer to these projects as the ones who cross the chasm. So this pretty much, they move from early majority to early adopters. They usually provide the industry standard within the area they operate in, and they are seen as stable and mature. Now, currently within CNCF, we have 127 projects which are in sandbox, 37 are in incubating, should be 36, because Cert Manager passed the graduation vote a few weeks ago, so we're going to have 27 projects which are graduated now. I would also like to draw your attention towards the faint green line you can see at the top of the graph. This represents our archive projects, and I don't think we talk sufficiently about archival. Sometimes it is natural for some of the projects not to reach that contributorship momentum or adoptership momentum, and I think it's very important for the maintainers to take the lessons learned and redirect their energy either to existing projects within the ecosystem or by creating new initiatives and open sourcing them. And currently we're focusing more on archival, and we have 9 projects with that status. Now, considering the ongoing success for Kubernetes and the growing cloud-native landscape, you might ask yourself why sustainability matters, and more importantly, why does it matter now? The short answer to this question is that currently we have multiple incentives to intertwine the economic growth with climate and digital sustainability. And this is because of 2 main factors. The first factor is COP21, which took place in Paris in 2015. This led to an international agreement to keep the global warming between 1.5 and 2 degrees Celsius. The second factor is the United Nations SDGs, or Sustainable Development Goals. SDG 13 focuses on climate action, and it emphasizes that as population of this globe, we need to think about our emissions in a more proactive manner. Now, both of these factors resulted with regulations at the national level, which in turn resulted with different organizations reporting their emissions. And we can see it in numbers as well. Currently, the tech sector is responsible for 1.4% of global GHGs, or greenhouse gas emissions. Now, if the tech sector had moved towards using renewable energy for powering their data centers and infrastructure, the amount of emissions would drop by 80%. However, if no action is taken, this amount of percentage is going to raise to 10% within the next decade. As you can see, tech sector plays a crucial role in this area. We need to drive remediation strategies, build expertise in-house, and ensure sustainability is thought about at every single decision-making process. And as part of this mission, we already have the big cloud providers setting net zero targets for themselves. And these are going to be focused on two main categories. The first one is going to be using renewable energy, and the second one is going to be offsetting their carbon footprint. Now, GCP is already running on renewable energy since 2022, with AWS and Azure aiming to do so by the end of next year. When we're looking into offsetting the carbon footprint, AWS aims to do so by 2040, with GCP and Azure aiming to do so within the next 6 years. In addition to that, we have Microsoft setting further ambitious goals for themselves, aiming to reduce deforestation, be water positive, and achieve zero waste certification. However, even if you use a cloud provider to fully provision your infrastructure, that does not mean that your sustainability point is checked off. You really need to integrate that within every single decision-making process and make it part of your production checklist. Now, this led to the creation of a new school of thought, which is known as GreenOps, that derived from the FinOps Foundation. GreenOps encapsulates all of the processes, tooling, cultural, and behavioral changes that relate to climate and digital sustainability. Now, way derived from the FinOps Foundation. This is because we can see a direct correlation between an efficient management of your infrastructure and having a positive sustainability impact. So for anyone new to FinOps, this is a practice that is concerning itself with observing the cost for your infrastructure and usually lowering that cost as well. So perhaps you might use spot instances, or you move from a SaaS solution to serverless, or perhaps you're changing the programming language to make it more optimized for the environment it is running. Now, all of these practices would usually result in your organization using less resources. Less resources means less cost, but less resources such as compute means less emissions. So by default, we can see this direct correlation between efficient management of your infrastructure and having a positive impact as well. And another thing to reinforce this link is that from the latest FinOps report, we can see that the sustainability and FinOps team are actually working in partnership more closely in the latest years. Now, at this stage, we can see that the tech sector plays a crucial role when it comes to addressing their emissions. The next question is, how can we apply or how can we measure our emissions within a cloud-native context? Well, for that, I'm going to introduce two tools. One of them is going to be Kepler, and the other one is going to be the KEDA Carbon Aware Operator. However, before I talk about any of this tooling, a quick show of hands, how many of you have heard about Kepler before? Nice. Okay, how many of you have heard about KEDA before? And the Carbon Aware Operator? Not some cool, amazing. So hopefully I'm going to take you through the journey today to ensure that you have something to research after this keynote as well. So let's start with Kepler. Kepler is a Kubernetes-based efficient power level exporter that uses eBPF to probe energy-related stats for your application and export them to Prometheus for data aggregation, from which we'll be able to visualize it with a tool such as Grafana. Now, Kepler was created by Red Hat and IBM in 2020, and it was donated to CNCF as a sandbox project in 2023, actually. Sorry, it was created in 2022 and then donated to CNCF 1 year later. Now, here I would like to put my TOC hat on. As you can see, Kepler is a sandbox project. It still provides this solution for a niche problem space. When we're talking about sustainability, it's still an emerging trend within our ecosystem. As such, if you're thinking about your emissions, or if you'd like to explore the idea of how to measure your emissions, I definitely encourage you to reach out to Kepler. But actually try out Kepler, but more importantly, to reach out to the community and be an active member of our ecosystem. It can be by providing just your feedback of using the tool in production, or perhaps you can open an issue on how to use this tool, or perhaps on creating new functionalities for this tool. Now, let's look into how Kepler calculates our emissions. The first thing we're going to have is our input value. And the input value is going to be the amount of energy consumed by your application. Kepler is going to calculate that in joules, and is going to convert that to kilowatt hour consumed. Next, we're going to multiply our input value by an emission factor. And the emission factor represents the pounds of CO2 or carbon dioxide emitted per emission gas. And currently, we're going to do so for three main gases, which are coal, petroleum, and natural gas. And as you can see here, these are hard-coded coefficients, and they really depend on the country, provider, or region you're actually running. And I definitely encourage you to kind of check these coefficients because you'll be able to use more granular data for your infrastructure. Now, the output value is going to be the amount of CO2 or carbon dioxide emitted per gas. Now, how this is all going to look like? I have deployed Kepler locally on a Kind cluster. As well, I'm running an application which is quite CPU intensive. In this particular case, I'm using the Kepler Grafana dashboard to visualize all of my data as well. So the first thing we're going to be faced with are three main gauges. These will showcase the amount of emissions per gas. In this particular case, for coal and petroleum, we have emissions which are quite high, which means we need to address them. For natural gas, it's looking quite well. At the top of the graph, you'll be able to also see the emissions factors, which are hard-coded in this instance. And I definitely encourage you to, again, update them to get more granular information about your emissions. In addition to that, with Kepler, we'll be able to calculate our emissions per container, day, and namespace. So for example, if you have a lot of traffic coming to your application, you have a spiky day, you'll be able to identify the application with most emissions and address that. If you have a namespace as a service solution, you'll be able to identify the namespace/team with most emissions and again, work with them to address that. However, these dashboards work in a reverse manner as well. You'll be able to identify the teams and the applications with less emissions. You'll be able to investigate that and create guidelines that are more personalized for your organization that you'll be able to share around and actually improve this knowledge sharing practice as well. Now, with Kepler at this stage, we are able to create an inventory of our emissions. We are at a very important step. If we can observe, we can address. The next question is, can we be more proactive in how we schedule our applications based on emissions? And this is where the KEDA carbon aware operator enters the picture. However, before I talk about the operator, I would like to very quickly introduce KEDA as well. Now, KEDA is a Kubernetes-based event-driven autoscaler that is allowing you to scale your application based on an event which is usually defined outside of the cluster. Now, KEDA was created by Microsoft and Red Hat in 2019. It moved to Sandbox in 2020, incubation a year later, and last year we were very happy to welcome KEDA as a fully graduated project. And again, I'm going to put my TOC hat on here. KEDA is a great example of a project that transcended different maturity levels all the way to graduation. It started with providing this solution for a niche problem space. How can you scale your application based on events outside of a cluster? It grew in adoption and contributorship to the point now it actually is an industry standard when it comes to scalability. Now, let's bring the spotlight back to sustainability. If you'd like to scale your application based on your emissions, we'll require a KEDA carbon-aware operator that aims to optimize your carbon efficiency and environmental impact by scaling your applications based on carbon intensity. Now, carbon intensity is going to be the grams of CO2 equivalent per kilowatt hour consumed. So what does it actually mean? If you'd be plugging your infrastructure directly into a solar farm or a wind farm, your carbon intensity is going to be zero or close to zero. This is because you have no emissions while consuming that energy. However, in a more realistic example, you're going to have multiple sources for your energy. Some of it can be from burning the coal and fuel, some of it can be renewable. As such, you're going to have a varied level of carbon intensity. Now, to scale any application with this operator, you require a carbon-aware KEDA scaler CRD or custom resource definition. And this is going to have three levels of configuration. The first one is going to be defining the application you'd like to scale. In this particular case, I'm referring to a scaled object CRD, which comes from KEDA with the name Mango Voyages. Next, I'm requiring the forecast for my carbon intensity. And there are two main ways to do so. The first one is to actually plug in directly into the grid and get this coefficient in real time. And some of the providers that allow this functionality are WattTime and Electricity Map. The second way is to use mock data, which I'm actually doing in this particular case. As such, my mock carbon forecast value is going to be set to true. And finally, towards the end, I would like to describe the behavior of how I would like to scale my application. The main idea here is that if my carbon intensity is high, I want the lowest amount of replicas because we have most emissions, so we want to reduce amount of replicas. And vice versa, when carbon intensity is low, we want to maximize our amount of replicas. And how is it going to look like? I have deployed this particular operator on my Kind cluster locally, and I'm able to visualize it in Grafana as well. There are two main lines I'd like to draw your attention. The green line at the top represents our carbon intensity. The yellow line at the bottom represents the amount of replicas. In this particular case, we're starting quite well. The carbon intensity is low, and we have 15 amount of replicas. Towards the middle, we'll be able to see that the carbon intensity is going higher, and the amount of replica is going all the way to 1. And this behavior is going to be replicated through and through based on the carbon intensity coefficient that you're going to be able to get from the grid. Now, so far, we are able to apply or measure our emissions within the cloud-native context by using tooling such as Kepler and KEDA carbon-aware operator. Now, whilst the technology is the gravitational point of our ecosystem, none of it would be possible without the community around it. As such, I would like to focus on this aspect as well. Now, from the beginning, the Kubernetes community operates on the principle that inclusive is better than exclusive. This is what pushes innovation forward and invites everyone to contribute. We build, create, and retain contributor communities for open governance, transparency, and a diligent code of conduct. Now, if you'd like to get involved with any of the CNCF projects out there, I definitely encourage you to check contribute.cncf.io, where you'll be able to find more guidelines and insights into how to engage with these projects. However, I cannot stress this enough. Contributions are not limited to code. You can be an active member of the community by being part of white papers or participating in different working groups. Perhaps you can create guidelines on how to use a specific tool or how to navigate a particular domain. All of this work is a valuable way for you to get engaged. And currently, we have most of this work, which is led by our tags or the technical advisory groups. These are micro communities with SMEs in the area, and they usually focus on a broader domain, such as observability, security, and lately we have the tag environmental sustainability as well. This tag aims to put sustainability on the agenda of all the CNCF projects out there. And there are two initiatives I would like to call out. One of them is the Green Reviews Working Group, which aims to measure your emissions. Actually, they aim to do so for the graduated projects, and they're currently working with Falco to create that prototype, and hopefully they will be able to replicate that for all other projects as well. And the other initiative they're working on is a white paper. So this is going to be a great way for you, again, to learn more about the space and get involved. And as a community, again, we need to remember that we are working on software that really changed entire industries and sectors and how we approach infrastructure build-out and management. However, at the same time, I would like to actually emphasize that we still further need to diversify our technical and governing boards and advisory committees. As such, I would like to encourage everyone here to continue building a diverse community. We need to always strive to create this welcoming space for new ideas and feedback to be welcoming, but at the same time for the next generation of cloud-native practitioners to operate in. And this brings me to the perspective today. So far, we talked about the notion of cloud sustainability and why it is important for the tech sector to address their emissions. We applied sustainability to the cloud-native ecosystem with tooling such as Kepler and KEDA carbon-aware operator. And finally, we talked about community sustainability and why it is important for us to scale at the same pace with the technology evolution. And all of this has been possible because cloud-native space is still going through a lot of transformation, but it reached a point where it encourages us to innovate for green technology by being aware of our environmental impact and carbon emissions. But more importantly, it encourages us to do so while building a healthy community. And without saying, we are hiring. If you'd like to work at Apple, I definitely encourage you to check jobs@apple.com, where you'll be able to find more details. If you have any questions in regards to the recruitment process or the experience of working at Apple, please reach out. If you have any questions in regards to today's talk, you can reach to me thereafter, or you can reach out to me on social media such as Twitter and LinkedIn. This is Gamanji, and I look forward to seeing how you can shape the cloud-native ecosystem. Thank you, and enjoy the rest of the conference.